Hey there, I have your daily GRE problem. This one's pretty cool. It goes over some sequences and sums of sequences, um, and just will serve as a good reminder to you that this is definitely something you should study before you go to the GRE. Even if it's unfamiliar to you right now, or if you kind of vaguely remember it from doing it in high school or something, it's actually not very hard. And there's just maybe 4 or so formulas to do arithmetic and geometric sequences and series. And I'll leave some links down in the description of this video to some Khan Academy videos and like practice links that'll let you practice this if you you know need to brush up your sequences and series skills. Anyways, but to the problem, here it is. So it says the sequence A is defined by a sub n equals a sub n minus 1 plus 2 for each integer n greater than or equal to 2. And the A1 is 45. What is the sum of the first 100 terms in the sequence A? And it gives you these options. So going through this, I want to point out a couple things. One, this sequence is a recursively defined sequence. That just means that the nth term is defined by the n minus 1 term, or rather the previous term, okay? So that's how they've given it to us. They've said that's their format. That's pretty easy to interpret, actually. So if we want, for example, and I'll use a different color, it probably will be a little easier. If I want A2, for example, A2 would be just A to the 2 minus 1 plus 2, or A1 plus 2, so just the previous term plus 2, and they gave us A1, so A2 is 45 plus 2 is 47. And then A3 would just be that previous term A2 plus 2, so it's 49. And so we can see that this thing goes 45, 47, 49, obviously it's going to go 51, etc. After you see that, if you're familiar with geometric and arithmetic sequences, you'd go, oh, hey, this is an arithmetic sequence. And so you might remember that an arithmetic sequence can be defined like this here, where it's the nth term is the first term plus some common difference, which in this case, the difference between the terms in the series is 2. It's like goes 40, 45, 47, 49, and the difference between those is 2. So first term times the common difference times n minus 1. And if you're thinking about this, you can convince yourself fairly easily that this different way of defining the sequence achieves the same results, okay? Remember that our A1, I wrote A1 in there, but I could have written 45. So this one is not recursively defined, okay? This one you can just put in any n you would like, and you can get out the nth term. And that's handy for us in this case, because you may also recall that the sum of an arithmetic sequence from 1 to n, and if you don't remember this, no worries, just go study the con links I'm about to give you. You'll definitely want to know this for the GRE. But at any rate, the sum of an arithmetic sequence is, from 1 to n, that is n over 2 times the first term plus the last term, or the nth term. So with this definition of A of n, it's much easier to do this problem now. We could say n, remember they want the sum of the first 100 terms. So we'll say n is 100. It's the number of terms, and the first term was 45, and the last term we can get with this here. So it's going to be Last term will be 45 plus 2 times 100 minus 1. Okay, one more parentheses there. Now we have a little bit of arithmetic to do, but besides that, this should be the right answer. So let's just see here. I'll just make that a 50. This is a 99. 2 times 99 is 198. 198 plus 45 is, let's see, 243. Okay. And then 45 plus 43 would be 290 minus 2 is 288. 50 times 288. That's going to be the same as 5. 5 times 2,880. Okay. And that's, let's see, 10,000. This part of the video is going to be kind of slow. Okay. 5 times 8 is 40, so that's going to be 400. This will be 4,000. This will be 10,000. So 14400. Okay, that seems pretty good. And there we go. That's answer B. Okay, so like I said, check the description. I'm going to go ahead and put some con links in there if you need practice with this sort of thing. Anyway, see you tomorrow. Bye.